Hi everyone. Today we're going to focus our attention on perpendicular lines. And this may come up later in the presentation, but just so you have an idea of what we're talking about before we start, perpendicular lines are lines that cross, but they have to cross in a very specific way. They always cross with a right angle in between them. Okay. So when we're talking about perpendicular lines, we're talking about lines that cross at a right angle. Okay. So the perpendicular transversal theorem says if a transversal, this is covered, I know I'm doing these a little out of order, so we haven't talked about the word transversal. A transversal is just a line that crosses other lines. Okay, and that will be covered in our lesson next week. Okay, so a line that crosses other lines. Okay. And this says if a transversal is perpendicular to one of two parallel lines, and I want you to look at this picture down here. These two lines are parallel, meaning they don't cross ever. If this transversal is perpendicular to one of them, then it automatically means that it's perpendicular to the other. Hopefully that makes some sense to you, that just from looking at this picture, if two lines are parallel and there's a line that's perpendicular to the first one, then it's going to have to be perpendicular to the second one. So that's what the perpendicular transversal theorem says. And I could prove this to you, but I won't be able to until after we do our lesson on Monday. So for now, just believe me. Okay, and then there's the perpendicular parallel theorem, which sounds very similar. But here's what this says. And this is also, by the way, I believe your book calls this something different. It calls this I believe your book calls it the two parallels theorem. That's kind of hard to read. I don't really care so much that you know the names of the theorems, as long as you know what the theorems do and what they represent. So this says, if two coplanar lines are perpendicular to the same line. So if I have these two lines, and I know that this is perpendicular and this is perpendicular, if those are both 90s, then I can conclude that these two lines are never going to cross. Think about that for a minute. See if that makes sense to you. If this is at a 90-degree angle and this is at a 90-degree angle, then hopefully you can see that these two lines are never going to cross each other. So again, if the two lines are both perpendicular to the same line, then the two lines are parallel. So this is sort of the reverse of what that last theorem was saying. The last theorem said if we know these are parallel and we know one is perpendicular, then the other one has to be perpendicular. Okay, so it let us conclude this. This one is saying if we know the two are perpendicular, then we know that the two lines are parallel. So it's almost like the converse. Not quite, but almost. Okay, so think about this for a minute. A swimmer gets caught in a rip current. Okay, so here's where they're swimming. A rip current is going to pull them out to shore like that. And then you're always told, and maybe you don't know this, but I lived in Florida for a while, and so I heard this all the time, that if you get caught in a rip current, you should swim parallel to shore. Why do you think that would be? Well, if you're out here swimming and you get caught in this rip current, it's sucking you out towards the ocean at large, and you start swimming parallel to the shore, that's going to be the quickest way to pull you out of that rip current because you'll be swimming perpendicular to the rip current. I think there's a picture that's going to show you better. Yeah. So here's your shoreline. If you swim parallel to the shore, you're really swimming perpendicular to the rip current, which will pull you out of it faster. Okay, just an interesting tidbit there for you. Okay, this we sort of reviewed yesterday, but this is going to be important in this lesson. So, slope is a ratio measuring the tilt of a line. We usually say it's rise over run, or y2 minus y1 over x2 minus x1. So this right here is your slope formula. Okay, this is going to be important to know. That's the slope formula. So, the slope of the line containing these 2 points. Here's how you go about this. I would call this coordinate number 1. And this coordinate number 2, this is x1 and y1 then, and this is x2 and y2. Okay, and I'm actually going to erase that today. Well, let's see. Yeah, I'll do that. Just so I have some room to work here. So if I'm going to do y2 minus y1, that would be the 5 and the 7. So I would do 5 minus 7 on the top over x2 minus x1 would be 6 minus 2 on the bottom. So 5 minus 7 is negative 2. 6 minus 2 is 4. And slopes I would always leave written as reduced fractions. So I would not make this 0.5, but I would make it negative 1/2 for your final answer. That's the slope that contains those 2 points, the slope of the line that contains those 2 points. Okay? Let's try another one. I'll put this one here so you can still see it. And now I've got 4, 0, and 10, negative 18. So again, I'm going to call this point number 1. I'm going to call this point number 2. I've got xy, xy. So x2 minus x1 would be negative 18 minus, I'm sorry, I think I said that wrong. y2 minus y1 would be negative 18 minus 0 over x2 minus x1 is 10 minus 4. Well, negative 18 minus 0 is just negative 18. 10 minus 4 is 6. This divides out to a whole number, so it comes out to negative 3. Whole numbers are okay, you just don't want decimals. You could write that as negative 3 over 1 if you wanted to, but really negative 3 is what I'd be looking for. Okay, let's try some. Okay, sorry, I forgot before we get to the examples, we've got a couple other definitions and theorems here to throw in. So, this is talking about perpendicular lines again, but specifically perpendicular lines on a coordinate plane. And on a coordinate plane, sort of the rule is two lines are perpendicular if and only if their slopes have a product, and remember, product means multiply, of negative 1. Now you're probably thinking, how the heck am I supposed to check all these and make sure they have a product of negative 1? Well, you don't have to, because there's sort of a rule of thumb. If you're looking for, if you have one slope and you're trying to convert it to a slope that would be perpendicular, it's always going to be the opposite, which means if it's positive, make it negative. If it's negative, make it positive. I'm sorry, my handwriting is so bad on this. Reciprocal, which means flip the slope over, like as a fraction. Opposite reciprocal of the original line slope. So let's look at these examples. It says give the slope of the perpendicular line. So my line right now has a slope of negative 3/5. I'm going to take that negative 3/5. I'm going to make it positive so that it's the opposite. And then I'm going to flip it over and make it 5/3. And that would be my final answer. Slope of 2, I would make it negative. And then remember, a 2 is really like negative 2 over 1. So when I do the reciprocal, it would be negative 1/2. And don't get too bent out of shape about where that negative sign is. When you're working with fractions, the negative sign is allowed to be on the top, or on the bottom, or just hanging out front. So if you put it down with the 2, that's perfectly okay. Okay, slope of negative 5. Well, negative 5 would switch to positive 5. I would put that over 1 and then flip it so it would become 1/5. And then slope of 1/7. 1/7 would become negative 1/7. And then I would flip it over and make it negative 7/1, which is really just the same as negative 7. So that's where I would leave my answer for that one. Okay, hopefully those are pretty straightforward. So hopefully you don't have questions on those. Give you a minute to copy them down if you fell a little bit behind. Okay, so let's look at this first example. Find the slope of a line perpendicular to the line with this equation, y equals negative 2x plus 1. This gives you way more information than you even really need. Because I'll tell you right now, the only piece of that equation we care about is the slope, which is the negative 2. Now, you may need a little review on this, so let me throw this out there really quick. Remember that we write linear equations as y equals mx plus b. The slope is always the number that's in the m position. Okay, so the slope of this line that I'm going to work with is negative 2. And then I just have to do what I was doing on the previous page. I'm going to make it the opposite, so I'm going to make it positive 2, and then I'm going to flip it over and it would become positive 1/2. I'm not convinced that you can see that yellow, so let me rewrite that real quick. Okay, so I took my slope. Oh, I don't know if you can see that any better either. Took my slope, negative 2. I made it a positive 2, and I flipped it over and made it a positive 1/2. And that would be the slope of the line that's perpendicular to that line. Okay, now, same question, except this one is not so easy because it doesn't give us the slope as easily. It doesn't fit that y equals mx plus b form. Now, by the time you hit algebra, you should be able to do this pretty quickly. What we're going to need to do here is we're going to have to solve this for y. We're going to have to get y by itself, okay, so that we can find the slope. So the key here is to solve for y, which means get y by itself. Okay, so the first thing I want to move, if I'm trying to get y by itself, here's my equal sign, so there's like a brick wall here. First thing I want to get rid of is this whole chunk, that whole 4x. So I'm going to subtract 4x and subtract 4x, and look at me, I'm using yellow again. Okay, that 4x is going to be gone, and now I have negative 3y. Now over here on this side, I can't really do 5 minus 4x. I can't actually subtract them because one has an x and one doesn't. And it would be okay to leave it as 5 minus 4x, but I'm going to put the negative 4x first, just so it looks more similar to that y equals mx plus b, and you can kind of already see it, right? You can see mx plus b. We just have one number left to get rid of, and that would be this negative 3. So I'm going to divide by negative 3. That means I divide everything over here by negative 3. Now, here I have negative 4 over negative 3. That doesn't really reduce, so I'm going to leave it as 4 over 3. But the fact that they're both negative, I am going to cancel out those negatives because two negatives make a positive. So I'm going to say 4/3 x, and then 5 over negative 3, again, does not reduce, but 5 over negative 3 would be the same as negative 5/3, so I'm just going to leave it like that. And that's kind of messy, but it actually doesn't matter, because remember, like the equation above, the only thing I care about after doing all of that is that slope, and the slope is 4 over 3. So that's where I'm going to start. Okay, I had to do all that work just to get the information I needed to solve the problem. I'm going to take 4/3, make it the opposite, so now it's negative 4/3, and I'm going to flip it over. So that would give me negative 3/4 for my final answer. Okay, you do have a homework assignment listed, should be on the front board for tonight. I will be available via email over the weekend, so if you do have any questions, please feel free to let me know. And if you email me about a question and I can't explain it very well, I'll do a video post similar to this one, and I'll put it up online for you to take a look at. So have a great weekend, and I want to say I hope to hear from you, but hopefully the homework goes easily for you so that you won't have to contact me. But if you do need any help, please let me know. Okay.